for you. Today, we are going to talk about arithmetic and geometric sequence, about how they work, how we'll solve them, and their different parts.
And now, let's finally start learning about arithmetic and geometric sequence. But first, what is sequence?
Sequence. A sequence is an ordered list of numbers that follows a certain rule or pattern. Example, 2, 4, 6, 8, 10, and so on.
So now, let us dive deeper and talk about their formula. So this is the parts of the formula in an arithmetic sequence. The general formula will be an equal a1 plus n minus 1d. So an will represent the nth term. We will show you how to get or how to solve for the nth term later on. A1 will be the first term, which means the first number in a sequence. D is the common difference, we will also explain that later, and n is the position of the term.
Parts of the formula in geometric sequence. The general formula is an equals to a1 times r raised to the power of n minus 1. So an represents the nth term, a1 represents the first term, r represents the common ratio, and n represents the position of the term.
Okay, let me actually tell you what D is. So D is called the common difference in an arithmetic sequence. For example, 5, 8, 11, 14, and so on. As you can see, they added 3 to the sequence, which makes the 3 the common difference.
R is called the common ratio in a geometric sequence. For example, 2 and 6 is we multiply by 3. 6 and 18 is we multiply by 3. 18 and 54 is we multiply by 3. So the common ratio is 3.
I will also give a short description about finite and infinite. So the meaning of finite sequence is it has an end, it also have limited number of terms. For example, 2, 4, 6, 8, it stops there, while infinite sequence goes on forever. For example, 1, 3, 5, 7, 9, and so on.
Geometric sequence is a list of numbers where each term is found by multiplying the previous term by a fixed, non-zero constant called the common ratio.
And now, for arithmetic sequence, it is a list of numbers where the difference between consecutive terms is constant.
Term to term is the step or operation to move from one term to the next. In arithmetic, it is when you add or subtract a fixed number, and in geometric, it is when you multiply or divide by a fixed number.
Now for the rule, it is the formula or instruction that describes how the sequence is built. For example, start with 2, add 3 each time. 2, 5, 8, 11.
Pattern: the repeated way the numbers are formed. Example, 2, 4, 6, 8. So the pattern is 2 because each term we add 2.
Okay, now last but not the least, the term. Each number in the sequence, for example, 5, 10, 15, 20, each one of them is called term. Okay, now let's start solving.
So for arithmetic sequence, here is the example: 6, 12, 18, 24, and so on. So first, we're gonna get the nth term. For the general formula is an equals to a1 times n minus 1 times d. So an equals to 6, which is the first term, then n minus 1 times 6 because our pattern is 6. So an equals to 6 plus 6n because we distribute, which is 6 times n equals to 6n, then 6 times negative 1 equals to negative 6, so 6 minus 6 equals to 0, so our n term is 6n. So now that we know the n term, which is an equals to 6n, so now let's try to find out next 3 terms. So first we'll get the 5th term, so a, then we'll get the 1, 2, 3, 4, 5 term, so a5 equals to 6, n is 5, so a5 equals to 6 times 5 is equals to 30. So our 5th term is 30. Then, so next we're going to get the 6th term. So a, and then n is equivalent to 6th term. So equals to 6 times 6, which is the 6th term. So next a6 equals to 6 times 6 equals to 36. So our 6th term is 36. Then next we will going to get the 7th term. So a, then the 7th term equals to 6 times 7, then a7 equals to 6 times 7 equals to 42. So for our 7th term is 42. So for geometric sequence, here is the example. So 160, 80, 40, 20, and so on. So how can we get the n term? So first, we'll get the general formula, which is an is equals to a1 times r raised to the power of n minus 1. So now for the n term, so an equals to 160, which is the first term. Then as you can see, our common ratio is 1/2 raised to the power of n minus 1. So next, so now as you can see, we cannot distribute anymore. So for our n term is an equals to 160 times 1/2 raised to the power of n minus 1. So now if we would like to get the next 3 term, how can we compute that? So using our n term, you can compute that. Let's put first the general formula, which is an equals to 160 times 1/2, our common ratio, raised to the power of n minus 1. So n is equivalent to 5, which is the 5th term, equals to 160 times 1/2 raised to the power of, which is the 5th term, so 5 minus 1. So a5 is equals to 160 times 1/2 equals to 4 because we subtract 5 minus 1. Then simplify it, it becomes a5 equals to 160, then 1/2 raised to the power of 4 is equals to 1/16. Then we simplify all of that, it becomes the 5th term equals to 160 times 1/16 is equals to 10. So for our 5th term is 10. The next, we're going to get the 7th term. First, we're gonna put the nth term, which is an equals to 160 times 1/2 raised to the power of n minus 1. So n replaced by 6, which is the 6th term, equals to 160 times 1/2, then 6, which is the 6th term, minus 1, then a6 equals to 160, then 1/2 raised to the power of 5 because 6 minus 1 equals to 5. Then a6 equals to 160, then 1/2 raised to the power of 5 is equals to 1/32. Then We simplify all of them and it becomes 160 times 1 over 32. The answer will become 5. So our sixth term is 5. Then next, we're going to find the seventh term. First, we're going to put the nth term, which is an equals to 160 times 1 half raised to the power of n minus 1. So n replaced by 7, which is the seventh term, then 160 times 1 half, then n replaced to 7 because of the seventh term, minus 1. Then a7 equals to 160 times 1 half. 7 minus 1 equals to 6. Then a7 equals to 160. Then 1 half raised to the power of 6 equals to 1 over 64. Then we simplify that. So a7 equals to 160 times 1 over 64 is 5 half or 2.5. So for our seventh term, we're going to put there is 2.5.
This is another example in arithmetic sequence. Negative 10, negative 4, 2, 8, 14, and so on. In order to get and know the next terms, we must first know the nth term. In order to get the nth term, we must follow the general formula, which is an equal a1 plus n minus 1 times d. The next thing we want to do is an equal negative 10 because negative 10 is the first term in the sequence, plus n minus 1 and 6 because it is the common difference. Next is an equal negative 10 plus 6n because we distributed 6 in n minus 1. So it becomes 6n minus 6. After that, we will add negative 10 and negative 6. So the nth term will be an equal 6n minus 16. Now that we know the nth term, we will find out what the next three term will be. So let us use the nth term, which is an equals 6n minus 16. Let's find the sixth term. An equals 6 times 6 minus 16. Then 6 times 6 is 36 minus 16. So the sixth term is 20. Now let's find the seventh term. An equals 6 times 7 minus 16. So first, 6 times 7. The answer is 42. Then we deduct 16 from 42. So the seventh term will be 26. Now let's find the eighth term. So 6 times 8, it will be 48. Minus 16, then it would be 32. So the eighth term is 32. And now for geometric example number 2, we have 1, 3, 9, 27, and so on. First, we will find the nth term again. So the general formula for geometric sequence is an equals a1 times r raised to the power of n minus 1. The next thing we want to do is an equal 1 because 1 is the first term in the sequence times 3 because it is the common ratio raised to the power of n minus 1. So an equal 1 times 3 raised to the power of n minus 1 is the nth term. And now let's try finding the next three terms with the nth term. First, an equal 1 times r raised to the power of 5 minus 1. The next thing I'll do is 5 minus 1. So it will be 1 times 3 raised to the power of 4. So it will be 1 times 81. And our final answer will be AN equals 81. That means 81 is the fifth term. Next, let us find the sixth term. Again, 6 minus 1, so it's 1 times 3 raised to the power of 5, and it will become 1 times 243. So our final answer will be A6 equal to 43. So that means the sixth term is 243. Now let us find the seventh term. So 7 minus 1, so it would become 1 times 3 raised to the power of 6. Then it would be 1 times 729. 1 times 729, our final answer would be 729. That means the seventh term is 729. Thank you.
So that's all for arithmetic and geometric sequence.
I hope you've learned something new today.
If you have any questions, please type it down below.
That's all for today.
Bye-bye!